Hello everyone, welcome to our next video of this series, Enzyme. And in this video, we'll cover the topic enzyme kinetics. Enzyme kinetics. The term kinetics, it signifies what? Kinetics means rate. Thus, for any reaction, for any phenomena, there should have some rate. If we considering kinetics of any phenomena, means rate of that phenomena. And for this enzyme also, this is a reaction because an enzyme reacts with substrate and ultimately product forms. Means there is a significant phenomena of product formation, and this also an reaction which also there should have some kinetics. Means enzyme plus substrate they form enzyme substrate complex, and from here enzyme dissociates and product form. Okay. Now this enzyme substrate formation, this is a reversible reaction, and from here enzyme and product form means there's some rate. And for deriving this rate equation, we actually follows Michaelis-Menten's equation. What is it is called? Michaelis-Menten equation. Because this equation derived by Professor Michaelis and Professor Menten. We all know for any molar concentration of anything, we denote by third bracket. Thus, for this equation, we will consider few things first. That is, I'll denote total enzyme concentration which is available for this reaction. Total enzyme concentration, it is ET. And from this equation we can understand this amount of enzyme is bound to substrate. Thus bound enzyme is what? ES. Consider ES. Means from that if you wanted to derive the free enzyme which is readily available for further reacting, that is free energy concentration or unbound enzyme concentration, which is total enzyme minus bound enzyme. Okay. Now let's go to some basics. For deriving rate of reaction, suppose A plus B is forming C. From the rate equation, we can understand rate of this reaction is basically depends on concentration of the substrate, that is A and B. From this is a basic rate theory, and same thing is applicable for enzyme as well. Thus, just understand these basics. This enzyme substrate complex. Now considering rate of enzyme substrate complex formation. Yes, it depends on what? Suppose the rate of formation is equal to K1. Thus, this is what? Breakdown of ES, that will consider K minus 1. And these are the rate constant. Thus, what is the rate of this formation? Rate constant K1 into substrate concentration. This multiplied by what? The enzyme which is free to take part in this reaction, that is Et minus Es. And what is the rate of enzyme substrate complex breakdown? This is breakdown in this way as well as this way, that is K2 Es, because this is the one which is reacting, right? Plus K minus 1 ES. Till time, I guess we all are in the same page. Now just considering the fact, the basic principle on which this entire enzyme kinetics stands, that is steady state assumption. Steady state assumption. What is this? This is very simple. Rate of enzyme substrate complex formation is equals to rate of enzyme substrate complex breakdown, means ES is constant. The concentration of ES is constant. The rate at which it is forming, at the same rate it is breaking. That is called steady state assumption, and on this principle the entire enzyme kinetics it stands. Now how it will then looks like? Very simple. K1 is ET minus ES equals to K2 ES plus K minus 1 ES. Right? Now let's simplify the equation. How it will be look like from here? K1 is ET minus K substrate and boundaries equals to ES, let's keep it as common, into K2 plus K minus 1. From here this is K1. K1 means this rate of this formation, this rate comes. From what we can write, K1 uh, from here it's like we can just give me a minute. If we take this fragment and this side, then it will be like this. K1 is ET equals to, then I will keep in this side and ES comes, I will take it as a common, ES multiply by K2 plus K minus 1 plus K1 S. Right? Till time we are on the same page. Then after this, from this we can consider this ES. Let's consider this fragment ES equals to what? K1 is total enzyme by K2 plus K minus 1 plus K1 S. Okay, then from here what we can do, this we can keep this K1 as a constant, and it will be looks like this. ES equals to is total enzyme divided by S plus K2 plus K minus 1 by K1. Fine. Now understand this fact. How the equation came? From here the equation came like this, and this fraction K2 plus K minus 1 by K1, this is called Michaelis-Menten constant, that is Km. Okay, so from this let's change the color. The equation will be like this. ES equals to S E T divided by S plus K M. Okay. Now, what is this rate of formation? What is? If we consider rate of product formation, that is a velocity of product formation. We can write it like from these, right? You can write it simply like this. Suppose it is this. Let's consider rate of this formation, product formation. Is entirely dependent on what? ES, right? It is entirely dependent on ES, and formation rate of formation is what? K2. This only this portion I am talking about. Only this portion. I'm talking about rate of product formation. From what we can write. If the rate of product formation is V naught, V naught equals to what? Rate constant is K2 and concentration is ES. Right? From this we can simply write like ES equals to V naught by K2. Now apply this equation here. What it really looks like? It will look like simply like this. V naught by K2, it will go upside, equals to K2 is ET by S plus Km. Okay. Now understand a thing. If the entire amount of enzyme, that is total enzyme, is turned into the bound enzyme, that will be the maximum velocity or maximum velocity of that reaction, right? If the entire total enzyme that considered into an bound enzyme. If ET, if this ES, this from the ET, that is the maximum enzyme concentration which is possible, then this is the maximum volume velocity. If bound enzyme, this concentration is nearly equals to total enzyme which is available, then this V naught will be the maximum velocity, that is V max. From that, what will happen? Then if K2 ET, it will be V max because bound enzyme reaches the maximum concentration of the substrate. From there, here what we can write? K2 ET is equals to KV max right here. Then K2 ET, it will be like V max, right? That is the maximum velocity possible. V naught equals to V max X plus S plus Km. And this equation is called Michaelis-Menten equation. And Michaelis-Menten equation is equal to what? V naught equals to V max S by S plus Km. Now, here's the interesting part. When this rate of reaction V naught equals to half of the maximum velocity possible, then what will be looks like? Half of V max equals to V max is by S plus Km. From if you simplify this Vmax because we'll cut it down, then 2S, there S, and it will looks like Km equals to S. Then if we wanted to find the value of Km, what the concentration of the substrate at which half of the maximum velocity of this reaction reached, means the substrate concentration at which half of the maximum possible velocity reached of any enzyme reaction, that substrate concentration is the value of Km, or Michaelis-Menten's constant. Graphically, the Michaelis-Menten's equation, it will look like what? Simple. It is a hyperbolic plot. It is a very important question for GATE. Means the equation will be like what? Here is the substrate concentration. This is the velocity. And it will be like this. Okay. And this is the maximum velocity. This is Vmax. And if this is maximum, suppose this is the half of Vmax. This is 4, then this is 2. Suppose the concentration at the substrate at which this velocity reached, this is called Km. And what kind of plot is this? This is hyperbolic plot. And this is all about enzyme kinetics and Michaelis-Menten's equation. Next class we will learn about different kind of plots which are possible for enzyme kinetics as well as enzyme inhibition. Thank you.